Hello students, welcome to Spectra Education Academy. In this video, I am going to continue the answers for remaining short answer type questions in the chapter Potential and Capacitance. First, let us discuss question number 6 because based on question number 6, there is a numerical. So first let us complete parallel combination of capacitors. So in parallel combination of capacitors, first you take 3 capacitors. So let 3 capacitors of capacitances C1, C2, C3 are connected as is shown. How means, let us say this is the positive plate of the first capacitor, this is positive plate, this is negative plate of the first capacitor. Similarly, positive and negative plate of the second capacitor, positive and negative plate of the second capacitor. Next, third, positive and negative plate of the third capacitor. All these are first connected at a junction. All these are first connected at a junction. Let us say this is junction B, this is junction A. Between the two junctions A and B, a battery which can produce potential difference between A and B is connected. So it means 3 capacitors C1, C2, C3. This is C3. This is C2. So consider 3 capacitors in which positive plates of all capacitors or first plate of all capacitors. Positive plates of all capacitors are connected at junction A. Connected at junction A. And negative plates of all capacitors. Plates of all capacitors are connected at junction B. At junction B. And finally, these two junctions are connected across the terminals of the battery. And finally, junction A and B are connected across the terminals of a battery A and B. A and B. So therefore, remember the potential difference across the plates of all capacitors. Across the plates of all capacitors is the same, which means V1, V effective even you can call it as, is equal to V2, V3 when they are connected in parallel. But the charge sent by the battery is added, the total charge or effective charge is equal to Q1 plus Q2 plus Q3. But we know that QE equal to CV. We can write Q1 equal to C1 V1, Q2 equal to C2 V2. But all capacitors are operated at the same potential. Q3 equal to C3 V3. So therefore, substituting Q total can be written as E effective with V. Q1 as C1 V1 plus Q2 as C2 V2 Q3 has C3V3. So therefore, C effective into V equal to, so we said that all capacitors are operated at the same potential. So therefore, C1V, C2V, C3V. So therefore, V cancelled, right? So the equation for effective capacitance is right. Now let us continue the next question, which is numerical based on the parallel combination of capacitors. Three capacitors, capacitances C1 equal to 2 microfarad, C2 3 microfarad, and C3 4 microfarad. They are connected in parallel. What is the total capacitance? So when capacitors are connected parallel, this is question number 4. C effective, we write it as C1 plus C2 plus C3. So therefore, they mentioned numbers as 2 microfarad, 3 microfarad, and 4 microfarad. So 3 plus 4, 7, 7 plus 2, 9. So answer is 9 microfarad. This is the answer for bit 1. And determine the charge on each capacitor they mentioned. So first we need to mention that because in parallel combination, potential is same. And the supply of potential also given in the question. That is 200 volts. So you need to understand like this. This is first capacitor. This is second capacitor. This is third capacitor. All are connected in parallel. And finally, there is a voltage of 200 connected here. But we need to find out Q1 here, Q2 here, Q3 here. So first let us find out the total charge. This is V equal to 200 volts given. So first let us find out total charge. So total charge means C effective into V. So C effective is 9 microfarad. That is minus 6 with 200. So this is equal to 18 into 10 to the power of minus 4. This is the total charge. So in order to find the charge on the first plate, Q1, Q1 equal to, you can say C1V because potential same. C1 is how much? 2 into 10 to the power of minus 6. So this is 2 microfarad into V is 200. So it will be 4 into 10 to the power of minus 4. Similarly, Q2 equal to C2V. So C2 is 3 microfarad with 200. So this is 6 into 10 to the power of minus 4. Q3 equal to C3V. C3 is 4 microfarad with 200. So this is going to be 8. 8 into 10 to the power of minus 4. So if you add them, 10, 18. So it is same as the total charge. Therefore, individually, charge stored on the first is 4 into 10 to the power of minus 4 coulomb. On the second, 6 into 10 to the power of minus 4 coulomb. On the third, 8 into 10 to the power of minus 4 coulomb. Now let us continue answer for question number 5. We need to go for the derivation. Derivation for the electric potential due to a point charge. Consider a point charge Q here. So there will be field around this. There will be field around this. We need to find out its potential at a point. When you place a point charge Q naught, which is brought from infinity, now it is placed in a field at a point P, and the point charge is placed at E. So which means consider a point charge Q at A. Let P be a point. P be a point where Q naught is a test charge placed at a distance at a distance x. So otherwise you can call it as this is point A. This is somewhere O placed. This is charge Q placed at O. Let A be a point where Q naught test charge at a distance x. At a distance x placed. Yeah, so therefore this is going to be x here. This is going to be x. But initially Q naught is brought from the infinity. Now, in case if Q naught is moved to point B within the field, so from A to B, through a distance A to B, from to point B through a distance against the direction of the field due to Q, against the direction of the field due to Q. So therefore dx is opposite to the field direction. So in general field starts at positive charge, goes to infinity. So therefore this is the direction of the field and direction of the force. So therefore force can be written as Q naught into E. Now work done by the variable force, because as you decrease the distance, the force also increases. So therefore this is a perfect example for the work done by variable force. So work done by variable force. So that is electrical force. Work done by variable force. Variable force. In general, it is represented with integration. So that is dW equal to F dot dx. So variable force. So limits are what? Limits are finally. Initially, it is brought from infinity. Finally, the Q naught is going to be placed at a distance R. So limits are going to be infinity to R. Since the charge is brought in opposite direction to the field, so if you remove dot product, f dx cos theta. So limits are infinity to R. So field direction and force direction is opposite to displacement. So therefore theta will be 180. So theta will be 180. Now dw equal to integration of f dx, theta cos 180 is -1. You'll get the expression like this. Now integration. So therefore integration of dx is just x. Keeping that in mind, this will be w minus, apply Coulomb's law here. So force expression is 1 by 4 pi epsilon naught q and q naught by x square is the initial distance into dx, and limits are infinity to r. So it is minus 1 by 4 pi epsilon naught q and q naught x to the power of -2 and dx infinity to r. So therefore x to the power of -2 plus 1 by -2 plus 1. This is the rule of integration, n plus 1 by n plus 1. So you'll get finally minus x to the power of -1. This will be -1 by x. So there is minus here, 1 by 4 by epsilon naught q and q naught. There is 1 by x here with limits and minus. So therefore finally 1 by 4 by epsilon naught q and q by x will get with the limits if you apply. So if you apply limits, it will be 1 by r minus 1 by infinity. So this is going to be the expression for work done or energy stored. 1 by 4 by epsilon naught q and q naught by r. So from the definition of potential, work done in moving unit positive discharge from infinity to a given point is called as potential. Work done is 1 by 4 by epsilon naught q and q naught by r whole divided by r. So therefore r and r q and sorry, this is q naught get cancelled. So v equal to 1 by 4 pi epsilon naught q by r. So this is the equation for the potential due to a charge at a given point. Thank you very much, students, for listening my class. In the next video, I'll continue with the explanation for short answer type questions from the chapter moving charges and magnetism. Thank you very much for once again for watching my video. And don't forget to share and subscribe with your friends and relatives. Thank you very much.